Hi everyone, in today's lesson we're going to talk about how to find limits algebraically where the value you're trying to find the limit for is a vertical asymptote. So we're going to do everything like normal. So the first thing we're going to do is we're going to plug in -1. We're going to try direct substitution. So let's plug in a -1 squared minus 3 times -1 minus 28 all over -1 squared minus 6 times -1 minus 7. So take a minute, type all that into the calculator, and then hit resume when you're ready for the answer. Okay, this time I didn't get 0 over 0 like the other problems. I got -24 over 0. So what happens when you get a number over 0, it means that the function has an asymptote at that value. So if we look at the graph, when x approaches -1, it looks like there's an asymptote. So whenever you get a number over 0, that means we have a vertical asymptote. We're still going to factor. So what I'm going to do now is factor the numerator and factor the denominator and see if I can cancel anything out. So x minus 7 and x plus 4 over x minus 7 and x minus 1. Plus 1. Alright, so I cancel the x minus 7's out, and now I'm left with x plus 4 over x plus 1. And I want to take the limit as x approaches -1. Now, what we would have done in the previous problems is that we would have taken this -1 and then plugged it in, and then that would have been our answer. But well, look what happens. If I plug in -1 again, I'm going to get 0 on the bottom. So this will be undefined. So there has to be another way. So we tried factoring and we simplified it. Now we're going to do something a little different. We know that if it's still undefined, if it's a number over 0, we know that there's an asymptote from the left and from the right. And we know that these asymptotes are either going to approach -infinity or positive infinity. So all we care about is if it's positive or if it's negative. So let's just see. If we plug in a number, so we have the limit as x approaches -1 from the right. We're going to plug in a number to the right of -1. So let's just say a number as close to -1 as we can. So let's just say -0.9. So -0.9 plus 4 over -0.9 plus 1. So do we agree that -0.9 plus 4 will be a positive number? And that 1 minus -0.9 or -0.9 plus 1 will also be a positive number. So we don't care what that number is, we just care that it's positive or negative. So if a positive divided by a positive is a positive, that means that the limit as x approaches -1 from the right will approach positive infinity. Right? Because if we have a vertical asymptote, we really only have two answers that we could have. The answer could go to positive infinity or technically negative infinity. So now let's try the limit as x approaches -1 from the left. So we're going to pick a number. We're going to pick a number to the left of -1, as close to -1 as we can. So let's just say -1.1. So -1.1 plus 4 over -1.1 plus 1. Now, if I take these two numbers on the top and add them, it'll be positive. And if I take these two numbers on the bottom and add them, it'll be negative. So a negative number divided by a positive number is negative. That's how we conclude that the limit as x approaches -1 is going down to -infinity. So if I am asking you to tell me what is happening to the limit as x approaches -1, the answer is technically the limit does not exist. So the limit does not exist. This is technically the answer. And the way you could prove it is looking at this graph. As x approaches -1 from the right, it's going up, And as x approaches -1 from the left, it's going down. And you see how the limit from the right and the limit from the left are different? Therefore, the limit does not exist. All right, let's try another example. So again, we're going to try direct substitution. So we're going to try to plug in -4 for every value of x. Okay, take a minute, pause the video, and hit resume when you're ready. Okay, I got -1 over 0. So because we have a number over 0, we're going to try factoring if we can. But it doesn't look like I'll find any factors of 16. The only factors of 16 that will add to 8 are 4 and 4, and that won't help me cancel anything out here. So factoring is unnecessary. So we could just write factoring won't cancel anything. So what that means is we're going to go straight to plugging in. We're going to find the limit as x approaches -4 from the right, and we're going to find the limit as x approaches -4 from the left. So to find the limit as x approaches -4 from the right, we're going to pick a number that's really close and to the right of -4. So let's just say -3.9. So -3.9 plus x over -3.9 squared plus 8 times 3.9 plus 16. And again, we don't care what the numbers are, we just care that it's positive or negative. I just realized I made a typo. This here should be a 3. So if I add -3.9 plus 3, the answer will be negative. And now let's see what will happen when I plug in the denominator into the calculator. So hit resume when you're ready. Okay, I got a positive number. And again, it doesn't matter what that number is, but I got that it was positive. So we now know that a negative divided by a positive is a negative. So this limit approaches -infinity. And that shows, on the graph. As x approaches -4, it goes down to -infinity. So now let's plug in a number a little bit to the left of -4. So let's just say -4.1 plus 3. -4.1 squared plus 8 times 4.1 plus 16. All right, take a minute, see if these items are both positive or negative. Okay, I got the numerator to be negative, and I got the denominator to be positive. So therefore, the limit as x approaches -4 from the left is also -infinity. Now, since the limit from the left is equal to the limit from the right, we could say that the limit as x approaches -4 is just -infinity. That is what it approaches. That is your answer. All right, let's move on to the back page. All right, the next example, I want to find the limit as x approaches 3. So we're going to try direct substitution first. I'll plug in 3 for x. Okay, hit resume when you're ready to see the answer. All right, I was able to get 4 over 0. So that means there's going to be a vertical asymptote. And when I looked at the factoring options that I have, the only factors of 9 that are going to add to -6 are 3 and 3, which won't help me cancel anything out here. So factoring actually fails here, so we could write that. So now let's take the limit as x approaches 3 from both directions. So let's see, as the limit approaches the limit as x approaches 3 from the right, and the limit as x approaches 3 from the left. So a number a little bit further right than 3, I'll say will be about 3.1. So 3.1 plus 1 over 3.1 squared minus 6 times 3.1 squared plus 9. So again, we want to see if it's positive or negative. We don't necessarily care how positive or how negative. So hit resume when you're ready to see the answer. Okay, I got a positive over a positive. So that means it must go to positive infinity. Now I'm going to do the same thing as x approaches 3 from the left. So I'll pick a number that's a little bit left of 3. So we'll say about 2.9. So 2.9 plus 1. 2.9 squared minus 6 times 2.9 plus 9. Alright, again, take a minute, pause the video, and hit resume when you're ready. Alright, I got a positive over a positive, which reduces to a positive infinity. And it proves the truth on the graph. They're both headed up towards positive infinity. So that would mean this entire limit as x approaches 3 goes to infinity. So we could write the limit as x approaches 3 of the function, which we'll call f of x, equals positive infinity. That is my answer. Alright, now I'd like you to try the next two problems for homework. So I'll label those as homework. And the answers can be found just by looking at the graph. But I want you to try to see if you can do it algebraically. Now, before you try this one, I actually would like you to change the limit. I wanted to approach the asymptote. I wanted to approach 2. So please change this as x approaches 2 from the left. Okay? So you can tell, as x approaches 2 from the left, the limit is negative infinity. And for the second problem, you can tell that as x approaches negative 5 from the right, the answer is negative infinity. So I want you to do the same thing that we did before, and I want you to find just the singular limit. I don't need you to find the whole thing. I don't need you to prove the limit from the right or the limit from the left here are not the same or are the same. I just want this left-hand side limit and this right-hand side limit. Do the best you can. I know this can be a little tricky, but we will go over anything that you need in class tomorrow. Okay, have a good night.